Good day everyone, I am Julhari Biabo from PS Social Work 1B. So my report is about Fibonacci sequence. So Fibonacci sequence, as we have seen in the previous section, the human mind is hardwired to recognize patterns. In mathematics, we can generate patterns by performing one of several mathematical operations repeatedly. Suppose we choose the number 3 as the first number in our pattern. We then choose to add 5 to our first number, resulting in 8, which is our second number. Repeating this process, we obtain 13, 18, 23, and 28 as the succeeding numbers that form our pattern. We call this ordered list of numbers as a sequence. Sequence. A sequence is an ordered list of numbers called terms that may have repeated values. The arrangement of these terms is set by a definite rule. Example: analyzing the given sequence for its rule and identify the next three terms. So A is equals to 1, 10, 100, and 1000. Letter B is 2, 5, 9, 14, and 20. Solution: A. Looking at the set of numbers, it can be observed that each term is power of 10. 1 is equals to 10 to the power of 0. 10 is equals to the 10 to the power of 1. 100 is equals to 10 to the power of 2. And 1000 is equals to 10 to the power of 3. Following this rule, the next three terms are 10 to the 4th power is equals to 10,000, 10 to the 5th power is equals to 100,000, and 10 to the 6th power is equals to 1 million. B. The difference between the first and second term, 2 and 5, is 3. The difference between the second and third term, 5 and 9, is 4. The difference between the third and fourth term, 9 and 14, is 5. The difference between the fourth and the fifth term is 6. Following this rule, it can be deduced that to obtain the next three terms, we should add 7, 8, 9 respectively to the current term. Hence, the next three terms are 20 plus 7 equals 27, 27 plus 8 is equals to 35, and 35 plus 9 is equals to 44. Check your progress. Analyze the given sequence for its rule and identify the next three terms. A. 16, 32, 64, and 128. B. 1, 1, 2, 3, 5, and 8. The sequence in Check Your Progress, item B, is a special sequence called the Fibonacci sequence. It is named after the Italian mathematician Leonardo of Pisa, who is better known by his nickname Fibonacci. He is said to have discovered this sequence as he looked at how hypothesized group of rabbits bred and reproduced. The problem involved having a single pair of rabbits and then finding out how many pairs of rabbits will be born in a year, with the assumption that a new pair of rabbits is born each month, and this new pair in turn gives birth to an additional pair of rabbits beginning at 2 months after they were born. He noted that the set of numbers generated from this problem could be extended by getting the sum of the two previous terms. Starting with 0 and 1, the succeeding terms in the sequence can be generated by adding two numbers that came before the term. So the example here is 0 plus 1 is equals 1, 1 plus 1 equals 2, 1 plus 2 is equals 3, 2 plus 3 is equals to 5, 3 plus 5 is equals to 8, and 5 plus 8 is equals to 3. So that's here at the right side is what we call the Fibonacci sequence. While the sequence is widely known as Fibonacci sequence, this pattern is said to have been discovered much earlier in India. According to some scholarly articles, Fibonacci sequence is evident in the number of variations of particular category of Sanskrit and Prakrit poetry meters. In poetry, Meter refers to rhythmic patterns of syllable. Fibonacci sequence has many interesting properties. Among these is that this pattern is very visible in nature. Some nature's most beautiful patterns like the spiral arrangement of sunflower seeds, the number of petals in a flower, and the shape of a snail's shell, things that we looked at earlier in this chapter, all contain Fibonacci numbers. It is also interesting to note that the ratio of successive Fibonacci numbers approach the number phi, also known as the golden ratio. This is approximately equal to 1.618. So it shows here that the farther the term, the closer we get to the real value of the golden ratio. So 1 divided by 1 is equals to 1.0000. 2 divided by 1 is equals to 2.0000. 3 over 2 is equals to 1.5000. And 5 over 3 is equals to 1.6667. 8 over 5 is equals to 1.600, 13 over 8 is equals to 1.6250, and 21 over 13 is equals to 1.6154. 34 over 21 is equals to 1.6190. 55 over 34 is equals to 1.6177. And 81 over 55 is equals to 1.6182. The golden ratio can also be expressed as the ratio between two numbers, if the latter is also the ratio between the sum and the larger of the two numbers. Geometrically, it can also be visualized as a rectangle perfectly formed by a square and another rectangle, which can be repeated infinitely inside each section. So here's the picture of the golden rectangle with the golden spiral. The formula for the golden rectangle is A plus B over A is equals to A over B equals to golden spiral or golden ratio pi is approximately equal to 1.61803. Shapes and figures that bear this proportion are generally considered to be aesthetically pleasing. As such, this ratio is visible in many works of art and architecture, such as in the Mona Lisa, the Notre Dame Cathedral, and the Parthenon. In fact, the human DNA molecule also contains Fibonacci numbers, being 34 angstrom long by 21 angstrom wide for each full cycle of the double helix spiral. As shown in the list above, this approximates the golden ratio at a value about 1.619. 1 angstrom is equals to 10 to the negative power of 10 meter or 0.1 nanometer. So this is the picture of Parthenon that is said to exhibit the application of the golden ratio. So next, exercise set 1.2. Let the Fib n be the nth term of the Fibonacci sequence with Fib 1 is equals to 1, Fib 2 is equals to 1, and Fib 3 is equals to 2, and so on. So question number 1. Find Fib 8. So question number 2. Find Fib 19. Question number 3. If Fib 22 is equals to 17,711 and Fib 24 is equals to 46,368, what is Fib 23? 4. Evaluate the following sums. A. Fib 1 plus Fib 2 is equals to blank. B. Fib 1 plus Fib 2 plus Fib 3 is equals to blank. And C. Fib 1 plus Fib 2 plus Fib 3 plus Fib 4 is equals to blank. 5. Determine the pattern in the successive sum from the previous question. What will be the sum of Fib 1, Fib 2 to Fib 10? Answer completely. 6. If you have a wooden board that is 0.75 meters wide, how long should you cut it, such as the golden ratio is observed? Use 1.618 as the value of the golden ratio. So, I'm going to explain how to answer this one. So right now, what I'm going to show you is how to find the value of the 8th term, because that's the first problem. So find the 8th term of Fibonacci. Find Fib 8. So what's the value of the 8th term of Fibonacci sequence? So I'm going to show you how to solve it using the formula of Binet's simplified formula, equals Fn is equals to value of phi minus, open parenthesis, minus value of phi plus parenthesis n term and plus parenthesis over square root of 5. So I forgot, may end dito. That's the Binet's simplified formula. So for finding the nth term, so what we need is first this one, value of n. And the nth term, what we are finding is the 8th term. So the n is equals to 8. Then what is the value of phi? Value of phi is equals to, in this particular formula, the value of phi that we are going to use is 1.618034. So it's easy. Now you can get this one by simplifying it, and 1.6180348 minus, don't forget the minus sign here, subtraction sign, then minus 1.6180334 close parenthesis, exponent 8, then another close parenthesis, over square root of 5. So I'm going to show you how to solve this one using scientific calculator. Now, in the previous video as shown, we already simplified the value for the formula that we're using. So f sub 8 is equals to, open parenthesis, 1.618034, exponent is 8, move it sideways, then put negative or minus, another open parenthesis for 1 minus value of phi 1.618034 close parenthesis, then exponent value 8, move it sideways, then another, and that one, then divide it by square root of 5. So the value is 21.000016724. So round off, so the value of it is 21. Based on the video shown of how I solved it using a scientific calculator, the value of f sub 8 is equals to 21. So let's find Fib 19. So the Fib 19. 19. F is equals to 19. So 1.6180349 minus 2 minus 1.61803 plus parenthesis 19, then plus parenthesis divided by square root of 5. So then right now we're going to save it again using scientific calculator. So we're going to repeat the process. Open parenthesis, value of 5, 1.6180334, exponent 19, then move minus, open parenthesis, 1 minus value of 5, 1.6180334, plus parenthesis, exponent 19, then close parenthesis, oh no, move muna natin siya para bumaba, then close parenthesis, then divide it by square root of 5. So it's 4,181. So the value of f so 90 is equals to 4181. That's it. So proceed tayo sa next question, which is number 3. If fig 22 is 17,711 and fib 24 is equals to 46,368, then what is the value of fib? So value of fib 23. So this is way to solve the question number 3 is just to subtract the value of fib 24 to value of fib 22. So 46,368 minus 17,711 over 2 7 5 2 6 baru 15 8 2. And the final value is fib 23 is 28,657. So the next question is that number 4, get the sums. So fib 1 and fib 2 is, the value of fib 1 and fib 2 is 1 plus 1 equals to blank, and value of fib 1, fib 2 and fib 3 equals to 1 plus 1 plus 2. So from the value of it, of the you'll get the value of 1 is this one from the given value on the first instruction. So the fib 1 is 1, fib 2 is 1 and fib 3 is 2. So the fib 4 is 3 because we just add the previous terms. So this is A, this is B, and this is C. So 1 plus 1 plus 2 plus 3. So we're going to get the sum of it. So it's 2, 4, and 7. Easy, right? So next, then proceed to the question number 5. Same problem, summation of the first term fib 1 to fib 10. So what's the summation of it? So the easiest way is that first you need to know the seventh term of the fib or Fibonacci sequence. So what is the seventh term of Fibonacci sequence? And we'll get it using the formula. And 7 is equals to 1.6187. The value of the seventh term is 13. That's it. Then after you get the value of the nth term or seventh term, the Fibonacci sequence, just need to times it to 11. So 13 times 11 equals to 143. So the answer from fib 1 to fib 10, value of it is 143. So question number 6. If you have a wooden board that is 0.75 wide, how long should you cut it such that the golden ratio is observed? Use 1.618 as the value of the golden ratio. So, first, given ng value ng ating width. Value ng ating width is 0.75 meters. Value ng ating golden ratio or phi is 1.618. Yan yung ginamit natin ngayon kasi tatlong decimal point lang ang kakailanganin. Then ang hanapin natin ngayon is yung length o haba ng wooden board nating ikakat. So anong formula nga ba? Paano natin gagamitin ito? First, i-illustrate muna natin. Katulad na nabanggit kanina, ang golden rectangle is binubuo ng isang square and isang maliit na rectangle. So here is A yung both sides ng square. Then B itong rectangle. So mahabang side is yun ang length nya. So it's AB or itong side nito is ang length. So itong mixing part naman is yun na yung width nito. So itong side na ito is ang width. So based on the So based on the formula sinabi ko kanina is phi. So phi is equals to a b equals to a plus b over a ay same lang ito sa length over width. Kasi nga kung mapapansin nyo, a plus b, so a and b, tama ba? So a and b sa taas, a and b, so ito yung length. Tapos sa baba naman, ang i-divide naman natin doon, ang pang-divide naman natin is itong width nya. So ito na yung a, itong side. So what is the value of, simplify na natin para ma-solve na natin. So ito na ang given, i-solve na natin siya. So ang formula na ating gagamitin is phi of E is equals to L over W, or length over width. So value of phi is 1.618, and the value of width is 0.75 meters. And so hindi naman natin to masosolve ng ganito lang. So what we are going to do is cross multiplication. So this is not a fraction, ito ay isang decimal. So meron na yan automatic, meron na yung 1 sa baba niya. So L times 1 is equals to L, and baba na lang natin to, natin to siya i-multiply. 8 times 0.75 meters. So ito na, solve na natin itong value ng length, ang haba niya. So 1.618 times 0.75 meters is equivalent to 1.2135 meters. So ito yung length na kakailanganin para mabuo ang makabuo ng isang golden ratio. So 0.75 meter, and ito ang value niya is 1.2135. So ngayon, itong rectangle or itong wooden board na ito is isa na siyang wooden board na base sa golden ratio. Kasi nga nasolve na natin ang width at saka ang length niya. So I hope nagets nyo ang aking explanation for this video. So you can ask me anything na hindi nyo nagets sa aking report. So that's all. Thank you.